This is a lesson on Newton's universal law of gravitation. Newton's universal law of gravitation states that any two bodies object in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This can be represented by the formula F, which is the force measured in newtons, equal to the G gravitational constant, which is 6.67 times 10 to negative 11 Newton meter squared over kilogram squares, multiplied by object 1, object 2 over the radius squared. That formula can be used in many applications such as figuring the mass of planets or the mass of an object. Another application is a practical application by finding out the forces between two objects exerted on one object. One of the problems commonly used is objects with masses of 200 kilograms and 500 kilograms are separated by 0.4 meters. A. Find the net gravitational forces exerted on these objects on a 50 kilograms object placed midway between them. B. What position, other than an infinitely remote one, can the 50 object be placed so it experience zero net force? For A, you can use the exact formula of object 1 minus by object 2 and simplify to get the net force. The sum of the forces equal to gravitational constant multiplied by mass 1 by the object over the radius squared subtracted by gravitational constant multiplied by the mass of object 2, the mass of the 50 kilogram object over the radius 2. You can simplify that to the gravitational constant multiplied by the object of 50 kilograms as it is the same in both equations, over the radius square as the radius is also the same, multiplied by the mass of object mass 1 multiplied by mass 2. When you plug in a number, you would get 6.67 times 10 to negative 11, which is the gravitational constant, multiplied by 50, which is the mass of the object that is placed midway between those two objects, multiplied by the differences between object 1 and object 2, which is 500 multiplied by 200, which would be 300 kilograms, over 0.2 squared. 0.2 came from the midway point. If the object 1 and object 2 is placed 0.4 meter away, the midway would be 0.2, and that is also squared. When you plug that into the calculator and produce an answer, it would be approximately 2.5 times 10 to the negative 5th Newton toward object that is 500 kilograms. Question 2 is what position other than an infinitely remote one can the 50 kilogram object be placed to experience zero net force? For an object to experience zero net force, meaning the two objects has to be in equilibrium. This is the reason why we set the gravitational formula for object 1 and object 2 equal to each other. It would be G, the gravitational constant, multiplied by the 50 kilogram object, multiplied by 200 kilogram object, over 0.4 meters, multiplied by the distance, and that is squared, equal to the gravitational constant, multiplied by 50, multiplied by 500 kilograms, over the distance squared. To solve for D, you can actually just cross multiply and get the answer. By cross multiplying, you're just canceling out the constant. Getting D multiplied by 10, cross multiplying would equal to the distance be about 2.245 meters. This is where the 50 kilograms object will experience zero net force. This is a simple explanation and a question that exemplify that is an example of how you use the universal law of gravitation formula in practical uses. Thank you.